Okay, now I mentioned it in the example, but entropy always increases. The only thing we can do here, the only thing we can possibly do is we can minimize it. We can make it zero, but we can never make the total amount of entropy we're generating for any process be negative. It could be negative for your system, but it will be positive for the surroundings, and those two either be equal, so entropy generation is zero, or there will be a positive value. It's always generating entropy. Okay, that's going to happen no matter what. So right here I have a cycle. I have process 1 to 2. It's process 2 to 1, internally reversible. I have process 1 to 2, which is either reversible or irreversible. I don't know what it is. It's one or the other. It can be either one. And so if it's irreversible, entropy is generated. If it's reversible, then that means that no entropy is generated. Okay, so for this guy right here, what we know is if both of these are irreversible, then this is equal to zero. The equality holds. If either one is irreversible, then it's an inequality, and it's simply saying that this value is going to be less than zero. This is the cyclic integral, and remember that this is connected to entropy. So let's go ahead and calculate entropy from it. So to do that, we're going to break it up so we have each process by itself. We have one that is internally reversible, the other one that is not internally reversible. And we remember that this right here was our definition of entropy. Okay, that's the definition of entropy. So I go ahead and put that in there. From 1 to 2, that's why I have the subtraction symbol right there. S1 minus S2. I have this other integral right here, which was not internally reversible, so I couldn't use my definition of entropy for it. And then I solve. And what I get then is, well, if I bring these both aside, how much did my entropy change from 2 to 1? How much entropy was generated going from 1 to 2? Well, that's going to be more than or equal to this integral. And so since this guy cannot be negative, ever, it's going to hold. It's going to say that my entropy, my change in entropy is always more than or equal to this value. Always. Always. And since I can never have a temperature that is infinity, I'm never going to have a total entropy change that is less than zero. Now, this is where you can say, well, what about heat? Heat can be negative because you're sitting out of the system. Yes, and we'll get to that in a minute. But overall, you're always going to have an increase in entropy for the total universe. I'll put it that way. And so when I talk about entropy generation here, I'm talking about how I have entropy change in my system and entropy change in my surroundings. I have to take both into account, and that's what's always more than or equal to zero. Like, yes, for my system by itself, or for even a little section of my system, it can be negative. But for the universe, it's always positive or equal to zero. Okay, and what creates this entropy? Irreversibilities. That friction, that unrestrained expansion, the mixing of fluids, the air resistance, anything that is wasting energy, that is increasing entropy. So, like I said before, though, you can have a isolated subsystem where your entropy change is negative. It's just that if you were to add all of the subsystems inside of this isolated place, you would see that, yes, subsystem 1, 2, 3, 4, 5, if I was to add them all up, they're going to still have some sort of entropy generated. I can also have my whole system have entropy be negative, but in the end, the entropy outside of that had increased and was positive, and it will always mean that the entropy is being generated, or the very best case, entropy generation is simply zero. Just know the entropy generation, when I take into account my system and my surroundings, can never be less than zero. That's why you hear like cool things in sci-fi movies like it's an anti-entropy gun or an anti-entropy engine. It's because it doesn't actually exist. Okay, last little detail here is that because we know entropy generation is always happening, it's zero at the best case, it's increasing otherwise. That tells us that is why we only have one direction for all processes. Since processes can occur in only one direction, in a certain direction, that is the direction where entropy generation is happening. Is entropy generation positive? That's the direction of this process. So entropy tells us what direction the process is going to go. Also, entropy is not a conserved property. There's no such thing as a conservation of entropy principle like we had a conservation of mass or conservation of energy. It's always increasing. And the only time you can ever have it be quote unquote conserved is during an idealized reversible process. During real world stuff, it's always increasing. And finally, if you're trying to figure out if something is doing well, we can use entropy generation to figure out how good of a job it's doing. If you're generating a lot of entropy, typically that means there's a lot of disorder, a lot of chaos. Think of your room when you're studying frantically for an exam. It's super messy. You've got 15 books out, the table's covered, you've got pencils everywhere, and it's a mess. You're trying to do it really, really fast. It's not the most efficient way to do it. Or maybe you study over a few weeks and your room is not nearly as messy. Or maybe it is. I'm not judging. I did not have the cleanest of rooms in college. Either way, remember this. Processes always move in the direction of increasing entropy. Okay, that's the important detail here. So that'll be it for this time. Thank you all so much. I'll see you later. Bye-bye.